Hi! Today we're going to talk a little bit more specifically about gas particles. We're going to explore the different phases of many different substances, and we're going to start by talking about gas particles. There are 5 keywords that you're going to get out of the video today that are used to describe how gas particles react in different situations. And here are the 5 words. Small, far apart, fast moving, space, and equilibrium. 5 words that I'm going to show you in an example that describe how gas particles are actually interacting all around me. There are gas particles all over the place because air is a form of gas. Okay? And it's probably one of the most common ones that when you think about gas, where you initially go. But you have to get to a point as a chemist where you flip a switch in your mind and you start to see things in a whole different way. From our element walk, hopefully you are starting to see things all around you. See where these elements are. See that this couch is made up of specific elements, that I am made up of specific elements, and so are you. And as chemists, we flip this switch so that we start to see the world in a whole new way. And that's where we are going to start today. So I would like for you to imagine that all around me, this air, that we can actually see it. Okay? And I would like for you to visualize these air particles as little dots all over the place. Can you see them? Not yet, I bet. But I want you to really imagine it. So this is the best scenario of imagining what an area looks like if we were to imagine air as little dots flying all over the place. What we have here is we have a syringe. Okay. And the syringe obviously has a stopper on it, and at the very bottom of the syringe you can see right here it is closed off or clamped off, and all of the light blue dots are the air that is existing in that little square world. All of the dark blue dots are the air or the gas that is trapped inside of the syringe and cannot get out. You can see that they are going all over the place. They're like kids at a school dance that have had too much Mountain Dew. They are really going back to those words. They are small. They are fast moving. And if you look between the dots, what is between those dots of air? There's nothing. There's just this space or this void in between the different particles of air that are flying around this little box that we are imagining. Let's focus for a second on just the air inside of the syringe. This is part of our virtual classroom, and you can definitely go and check this out on your own. I can pull the plunger up. When I give that air or gas that's trapped inside the plunger the most space that it possibly can, you can see that it is quick moving, that they travel in a straight line and then bounce off of it and then travel in the opposite direction. They are trying to get as far away from the other gas particles as possible. You can see here that we're keying into our words. Small, they are far apart from the other particles, and they are fast moving. And in between those gas particles, all there is space. If I push the plunger down, they still want to take up as much space as possible. However, I'm giving them much less space to move. So you can actually force the gas particles to become closer to each other, but can I push the plunger all the way down? No, I can't. I'm trying. I'm literally trying with the mouse, and I cannot push the plunger down all the way. You will actually get a chance to explore this situation in real life later on this week by exploring some syringes with air trapped in them. And why can't I push the plunger all the way down? Because the gas takes up space. Those gas particles can't be touching. Okay? They take up space. They have that space in between those other particles. And they are trying to get away from the other gas particles. They are just really filling and will fill the entire area that you give them. Now, let's add in our surrounding air again. And it's crazy. We have the light blue and the dark blue. I'm going to grab a hold of the plunger here, and I am going to push it down as far as it can go. As you can see here, the other particles from the air start to come in on the other side. The outside air, that surrounding air, starts to come into the other end of the plunger. And the air particles inside the plunger are trying to push up and push out and push around on that plunger's top or bottom. If I let go, what happens? The plunger starts to rise. Why doesn't it go all the way to the top? The last word is why it doesn't go all the way to the top. Because the air particles have reached an equilibrium with the air particles outside of the syringe. Equilibrium, the definition for equilibrium, you can see at the bottom of your screen. So the key words here to remember about gas particles. Think about examples. How would you explain gas particles to someone else who have never, quote, seen gas particles before, as we see them with little dots moving around quickly? Okay. Gas particles, think back to those words. They are small. They are far apart. They are fast moving. They have space in between them. And they want to reach an equilibrium. All right? We will leave off with gas particles here for today. Signing off on gas particles. Next time I talk to you, we'll be exploring other types of particles, perhaps liquid or solids.